We're looking at the sky from North Georgia on Halloween night, October 31st, about 8:30 p.m., facing east. We see a sky filled with stars. The stars form patterns in the sky that lead us to areas called constellations. Constellations are areas of the sky with defined borders. They're kind of like states on a map. Anywhere you point on a map of the United States, you point within the borders of a state. And anywhere we point on the sky, we point within the borders of a constellation. These are the borders of the constellations in the sky that we're seeing. And we're going to look for our first constellation about halfway up the sky towards the east, Pegasus. We look for Pegasus by looking for a large square of stars, 4 stars, that form the Great Square of Pegasus. And here in the outline you can see the square as well as sort of the head of Pegasus and 2 front legs. In the sky we sort of see the front half of Pegasus. And in Greek and Roman mythology, he was a winged horse, and whenever his hoof struck the ground, it was said a river of inspiration would spring forth. The star that's in the bottom left corner of the Great Square of Pegasus is actually shared with another constellation, the constellation Andromeda. We can look for Andromeda by looking for that star Pegasus and then 2 branching lines of stars off of it. The top line is forming sort of a ghost image of the bottom line. And that's the body of Andromeda. So I'll put up the picture here. Andromeda in Greek and Roman mythology was a princess. She was the daughter of the Queen of Ethiopia, Cassiopeia. Now, unfortunately, Andromeda's mother used to brag about her beauty, that she was more beautiful than the nymphs of the sea. This angered Poseidon, who kidnapped Andromeda, chained her to a rock, and sent a sea monster after her to eat her. The sea monster is actually in the sky as well. It's a bit low on the horizon to the east, below Andromeda. We can find sort of a smaller square of stars near the very bright full moon, towards the bottom middle of the screen there. And that is the head of the sea monster, Cetus. Sometimes called the whale, but in ancient stories, it was more of a terrifying sea monster sent to devour Andromeda. But Andromeda was rescued just in time by the hero Perseus before Cetus could eat her. Now, there are other cultures around the world, different stories and pictures in the sky. So for people in ancient Greece, these stars were a sea monster for Cetus. But for people that lived in Brazil, the same stars were sometimes known as a jaguar. This jaguar, I'll put up a picture so we can see it better. This jaguar was connected to a god of violent storms. As I mentioned, we have the moon in the constellation Cetus. You can see it there low on the horizon. It's rising to the east. And it's not just a full moon, but a blue moon. This Halloween night, we will have the second full moon of the month of October. The moon orbits around the Earth once every about 29.5 days. It's a little bit shorter than most of our calendar months, and so it's possible to have 2 full moons in 1 month. It's somewhat infrequent. It'll happen about every 2 to 3 years, and so we get this phrase of once in a blue moon. There was a full moon at the beginning of October. That was the harvest moon. That was the moon closest to the fall equinox. That was in September. And so this second full moon of October is our Halloween blue moon. And when we have a blue moon, it means there's 13 full moons in the year instead of 12. The moon won't be blue in color, unfortunately. The moon can appear blue occasionally, locally in an area if there's smoke or dust particles in the air. They have to be a certain size. If we have bits of smoke or dust that are about 1 micron wide, then they can scatter away red light, and we see the moon sort of tinted, sort of like a filter, where it looks more blue. And that would be a very rare sight indeed. The moon has often been a source of inspiration for stories, especially involving the strange and mysterious. The classic spooky tale began under the light of the moon, Mary Shelley's Frankenstein. Mary Shelley was only 18 when she wrote Frankenstein, over 200 years ago. Let's travel back in time to the year she started writing it, 1816. The screen will go dark. We're going to bring up the sky. This is the sky from Georgia, June 15th, 8 p.m., 1816. Now, Mary Shelley wouldn't have been in Georgia. She would have been staying at a villa in Switzerland near Lake Geneva. She was staying with friends that summer. So let's go ahead and lift off the earth and fly to where she was staying. Flying above Georgia, we'll head over to Switzerland in Europe, where it's later in the night. It is now 2 a.m. on June 16th, 1816. Mary Shelley wrote about the night she envisioned Frankenstein. Her and her friends had spent several rainy days indoors. One of her friends was the poet Lord Byron, suggested they all try to come up with creepy stories. Mary Shelley couldn't think of anything at first. She spent days pondering, wrapped in deep discussions about the nature of life with her friends, including the recent discovery that electricity could cause dead bodies to jump and twitch. Mary Shelley herself wrote about that night. Even the witching hour had gone by before we retired to rest. When I placed my head on my pillow, I did not sleep, nor could I be said to think. My imagination, unbidden, possessed and guided me. I saw with shut eyes, but acute mental vision, the pale student of unhallowed arts kneeling beside the thing he had put together. I saw the hideous phantasm of a man stretched out, and then on the working of some powerful engine show signs of life and stir with an uneasy, half-vital motion. Behold, the horrid thing stands at his bedside. Opening his curtains, I look on him with watery, yellow, but speculative eyes. I open mine in terror. I see them still, the very room, the closed shutters, the moonlight struggling through, and the sense I had that the glassy lake and the white high Alps were beyond. On the morrow I announced I had thought of a story. I began that day with the words, "It was on a dreary night in November." When Mary Shelley wrote about that night, she didn't mention the exact date or time, but we were able to figure it out. Astronomers figured it out a few years ago because the villa is still standing in Switzerland, and they used her clue about the moonlight. They could go to the villa, to the room she stayed in, and figure out what phase and angle we would need for the moonlight to come into the window through the shutters past midnight, the witching hour. And they found that on June 16th, 2 a.m., it would have been just right in 1816. We see that inspirational moon here. It's very low on our view of the sky, just above the horizon, near the bottom of the screen. It's a waning moon, so it's in the process of going from a full moon to a new moon, the moon getting a little smaller each night. Let's fly out to the moon and take a closer look. We're lifting off Earth again, and this time flying out to the moon, traveling over 240,000 miles through space. So here we can see the moon much better, closer up. The moon is smaller than the Earth. If you were standing on the surface, you'd only weigh about 1/6 of what you do on Earth. And there's only been about a dozen people who ever experienced this, standing on the surface of the moon. During the Apollo missions in the 60s and 70s, we sent people to walk on the moon and explore. We're going to take a look at a photo of the last time people stood on the moon, the Apollo 17 mission. This was a mission that landed on the moon in 1972. And here we see their landing site, part of the lander that was left behind, as well as foot trails. Even trails, sort of a double line trail, that's the tire tracks from the buggy that they drove across the surface so that they could get further across the surface. They collected moon rocks and volcanic glasses to bring back to Earth that we can study, that we're still studying today in labs. That was the beauty of bringing them back to Earth, as we had samples that we can continue to look at with better and better technology. We actually tend to study the Earth today with orbiting spacecraft. This photo was taken with the Lunar Reconnaissance Orbiter. And so if we want to see any of the Apollo lunar landing sites, we typically do need to look at photos from an orbiter that gets closer to the moon to see those pictures. There's another orbiter that's at the moon now. It's an Indian spacecraft called Chandrayaan-1, orbiting the moon. It does carry a NASA-developed instrument called the Moon Mineralogy Mapper. We're going to take a look at a map that it made of the surface of the moon. So here we see the map, and this is showing us infrared light. So infrared is lower energy light than what we see with our eyes. And what we see here is 3 very narrow ranges of infrared light, where each one has been colored with a different color, so we can look at where some different materials are present in the rocks on the moon. And so we see blue areas towards the poles of the moon, and that's actually showing us where there's water and hydroxyl. The water is bound up in the chemical composition of the rocks. It's not liquid water flowing on the surface or even frozen ice. This is water that's sort of structurally in the rocks on the moon. The red is showing us traces of an iron mineral called pyroxene. Scientists were interested in studying the blue areas towards the pole in more detail, so they used spectra. Spectra is when we take light and we spread it out into a rainbow, separating out each wavelength of the light. It lets us get a signature that gives us a more detailed view of what's in the surface. And so a recent paper from this year found that hematite is present in some of those polar areas. Hematite is a form of rust, an iron oxide, and it's only known to form in the presence of water, actual unbound water, and oxygen. And that's difficult to find on the airless, dry moon. This is a mystery that still remains unsolved, but the authors of the paper that came out, they suggested a possible scenario. In the ancient past, the moon was closer to the Earth. Every day it moves a little further away from us. And when it was closer, it would have spent more time within the protective magnetic fields of the Earth. Those magnetic fields may have even lifted small amounts of oxygen from Earth's atmosphere to deposit on the moon. There could be meteor impacts, small dust particles even striking the moon that would release some of the water that's already locked into the structure of the rocks there. And so this process could have allowed that hematite, that rust, to form on the moon that we're seeing. But we still need to study more to figure out if that's what's happening. Being able to collect more rocks from the surface would be a very helpful way to study this further. NASA hopes to send people back to the moon again. The Artemis mission is planned to get the next man and first woman onto the moon by 2024. And hopefully we'll unravel more mysteries about rocks on the moon, as well as test out the technology to take people further out into space.